Normally, I try to record videos in my office so that I'm not interrupted while I do them. But tonight, thanks to Hurricane Matthew, I am working from home in order to get you the videos that we need. So I need to know, what are the odds that I, Dr. Stuckey, can make it through the videos uninterrupted by my children? So I think that that might be a feat to be accomplished, but let's see what the odds say. So what I'm going to show you tonight is a Poissan distribution and an exponential distribution. So let's, before I calculate the odds that I can make it through the video uninterrupted by the children, let's go through some business examples. Say that you're working at a call center and that you average 30 calls an hour. You want to know what are the probability that you will have 60 calls in 2 hours. To find that, you can use a Poissan distribution. All right, so first you've got to calculate your mean. Well, you already know that your mean is 30 calls per hour. And so now you're looking for the mean over 2 hours, so that's just 60. So 30 times 2 is going to give us 60. I always like to link all my cells because when you get into problem solving to decision making, you have to, or your problems just won't come out right. Okay, so what is the probability that you're going to have 60 calls in 2 hours? Let's use our Poissan distribution. Okay, so you can start typing it, click it, and if you want to use the box, once that comes up, you can hit insert function and it'll bring it up for you. All right, so X is our number of events, and what we want to find out is what is the odds that we're going to have 60 calls in 2 hours. So we're going to hit 60 as our X. Our mean is our average, which is this cell C4, which is also 60, and our cumulative. Now this is the same as before. That is that if it is true, that it will give you the odds for 60 calls and below. If it's false, it will give you exactly 60. In this case, we want it to be false. Okay? And my odds are that we, about a 5% chance that we're going to have exactly 60 calls in 2 hours, even though our mean is 60. All right, now let's calculate the probability that we're going to have 60 calls or less in 2 hours. So we use the same Poissan distribution. Okay, our X is still 60. Our mean is also still 60, but now we are going to put true instead of false for our cumulative. All right, and now we find that we have a 53% chance of getting 60 calls or less in the 2 hour period. Now let's calculate the probability of between 50 and 100 calls in 2 hours, and that needs to be inclusive of both 100 and 50. All right, so do our Poissan distribution. And again, well, our first one is going to be 100. We're going to calculate the odds of 100 or less. So our mean is still 60, and we want this to be true because it's going to be, again, 100 calls or below. All right, now we are going to do the next Poissan distribution. Okay. And what we're going to do here is our X is not going to be 50, because if we made our X 50, it's the same thing as when we did it with the binomial distribution. Then we would actually end up with a calculation for 51 to 100 hours, and it needs to be inclusive of 50. So we need to subtract the probability that you will have 49 to 0 calls. So that is why that X is 49, your mean is still 60, and your cumulative probability here is still true. And we need an extra parentheses. That's fine. I'm going to go ahead and select that. And we have a 91.5% chance that we will have between 50 and 100 calls in 2 hours. Now this same business owner wants to calculate the probability that there will be 5 minutes or more between calls, 10 minutes or more between calls, 15 minutes or more between calls, and I'll do the 20 minutes when I do my own problem. Okay, so here's what we need to do. In order to use we're going to use an exponential distribution in order to do this. And in order to use an exponential distribution, we need to calculate the lambda, which is 1 divided by the mean. So You literally do 1, and you divide that by the mean time between arrivals. Now let's talk about how we calculate the mean time between arrivals if you have to use that at some point. So if you have 30 arrivals per hour, it's 1 divided by 30 would be your mean time between those arrivals. Okay, and so then your lambda is just the 1 divided by the mean, so 1 divided by 0.033 then equals 30. Okay. So what are the odds that you will have at least 5 minutes between arrivals? You're going to have to use an inverse here, because when you use the actual exponential distribution, it would give you what are the odds of 5 minutes or less. And so we want 5 minutes or more, so we're going, or more than 5 minutes, so we're going to do 1 minus, and we'll get our Poisson our exponential distribution up, expon.dist. And so first we need our x. So our x is our time between arrivals, and I need to show you how to get that. I'll do that next. We want that to float, so I'm not going to make that an absolute value. Next we need our lambda, which is our 1 divided by our mean. We're going to make that an absolute value so that we can copy it, and our cumulative in this case is going to be true. Okay, so we have an 8% chance that you are going to have 5 minutes or more between arrivals. All right, let's talk about how they got this number, because it's kind of important. All right, so because this is in minutes, okay, you have an arrival expected basically every 0.03 minutes, then this has to be in minutes as well. So to do that, we do 5 divided by 60 to get 10 minutes. We do 10 divided by 60, 15 minutes, 15 divided by 60, etc. All right, so now that we have done this, we can just copy and paste it down. And so we find that there is less than a 1% chance of 10 minutes between arrivals and less than a 15-minute chance. I'm sorry, there is substantially less than 1% chance for 15 minutes between arrivals. So let's go back to my original question. I have 2 precious children, and I estimate that they come in about, we'll call it about every 6 minutes. So we're going to do 6 divided by 60, okay? And then we're going to calculate our lambda, which is our arrival time. I'm sorry, it's 1 divided by our arrival time. There we go. Okay, so basically I get interrupted about 10 times an hour when I'm at home making videos. All right, so now let's use our exponential distribution to figure out what are the odds I can make it through a video without you hearing my sweet children's voice in the background. So 1 minus our exponential distribution. We're going to use the same x over here since it's already calculated for us, but I'm going to go all the way to 20 minutes because even though the videos are only 15 minutes, it actually takes me more like 20 to 30 minutes and sometimes longer to produce them. All right, our lambda is this 10, and we're going to use true because I'm looking for or more. So this is going to calculate what are the odds of going 5 minutes or less, and then when I do the 1 minus, that's going to give me the odds of more than 5 minutes. Okay, so let me go ahead. All right, so I have a 43% chance of making it through 5 minutes without being interrupted. I forgot to make this F13 an absolute value so I could copy and paste. I went ahead and did that. Now I can copy and paste this formula down. And by the time we get to 20 minutes, I have a 3% chance. So I've got a reasonable chance for a 10-minute video, maybe 18%, and an 8% chance at a 15-minute video, and a 3.5% chance to get a 20-minute video in uninterrupted by children. So you may ask, Dr. Stuckey, this is almost a 10-minute video already. How come we haven't heard their sweet voices? Well, understanding that this was the case, I sort of stacked the deck. After the winds and rains of Hurricane Matthew moved on, they decided they wanted to go home with their grandpa and carve pumpkins and make pumpkin pie. So that is what they did, and that's why you don't get to hear their sweet voices tonight. However, I'm sure if the situation presents itself in the future, you very well may hear their sweet voices on video. And you also have a case in point of why these are usually done in the office and not at home. All right. So I hope you've enjoyed this video. I hope it's helpful as you complete your homework. And if you have any questions, feel free to call or email. Thanks.